Okay, now we're going to take a look at simple harmonic motion. So we come up here and we look at our two formulas. For up and down motion, we use the sine curve. All right. And for left and right motion, we use the cosine curve. So we just need to be aware of that. That's when you use sine or when you use cosine. So a ball is bobbing up and down on the end of a spring. That sounds like we're going to use sine. Okay. Suppose that 10 centimeters is the maximum distance the ball moves vertically upward or downward from its equilibrium position. The time it takes the ball to go from its positive max position to its negative max position and back is 4 seconds. From this, the period would be 4 seconds and the amplitude would be 10. So that's some information that we need. Okay, so let's write the equation for the simple harmonic motion of the ball and determine the frequency for this motion. Okay, so our equation is D equals A sine, you could call it W, T. Okay, so we know the amplitude. We've established that the amplitude is 10 because you're bouncing up and down. The max is 10, so you're going a maximum of 10 up or 10 down. And then the period is 4. So filling out some of the information, this is going to be 10 sine of something. So we have to figure out what the period is. We're not going to put anything in for t. T is a variable. So remember, the period is 2 pi over b. 2 pi over b. But whenever you get into harmonic motion, we call that w instead of b. So b is w, w is b. It really doesn't matter what you truly call it as long as you know that's the period, how you change the period number. So we know the period is 4. And that's 2 pi, and that's w. So you got to solve for w. So cross multiply, or just multiply both sides by w. So for w equals 2 pi. So then what's w? 2 pi over 4, which is pi over 2. So our equation is 10 sine of 2 pi t. I'm sorry, I said 2 pi. Pi over 2 t. All right, and then it says determine the frequency of this. Okay, so frequency is b over 2 pi. All right, so really it's this, you're trying to find this number. Okay, so we're going to take frequency equals pi over 2 over 2 pi. Like how many times does it occur in a whole cycle is another, maybe I should have phrased it that way. That's the frequency. How often does it occur in that time frame? So that's a 1/4. Okay, 1/4 cycle per second. Okay, think about it this way. The period's 4 seconds. So how far does it go in pi over 4? It goes 1/4 the time. It's going basically that distance in 1 second. Okay. Questions? Hopefully that makes sense. All right, so now we're going to switch gears a little bit, and we're still going to focus on the same types of questions, but they give us the equation here. I'm just trying to give us some more space to work on this a little bit. I'm going to go to the next page. Give ourselves a little space to write. I had enough space. Here we go. Determine the equation, given the equation for simple harmonic motion, D equals 6 cosine of 3 pi over 4t. Determine the following. So we need to determine the maximum displacement. We need to determine the frequency. We need to determine the value of D when t equals 4. And then we need to determine the least positive value of t for when d equals 0. Those are the things that we have to decide. So let's find the maximum displacement. So if you think the maximum displacement is if this is the level or the calm of the boat, if you want to think of it as a boat. Okay, I know cosine weren't going this way, but it's easier to think of it. So how far up does the boat go, or how far down does the boat go on the waves? Like how big are the waves is what we're really thinking about. And so there's really no work to figure out here for letter A. The maximum displacement is just the amplitude, the absolute value of it. So the absolute value of 6 is 6. That's the maximum displacement. So didn't really need all that space, but we had it just in case. Okay. So next we need to find frequency. And frequency, the formula for that is W over 2 pi. Now you can think of it as B over 2 pi. So that's a frequency. I haven't really talked about that yet until we got into simple harmonic motion. So where's W? W is B. So this is B or W. So it's 3 pi over 4 over 2 pi. So if you're want to leave the pi's out of it, you can let the calculator do the work. Or if you're not sure how to type it in the calculator, you have to write it as a complex fraction sideways. So it's 3 pi over 4 times 1 over 2 pi. So the pi's are going to cancel, and you're going to get 3 over 8. And that's, if you want to think of units, that's cycle per unit of time, whatever that time frame is, whether it's seconds, minutes, hours. It's going to change from one, but that's what the reciprocal of the period is really what the frequency is. It's the reciprocal of the period. That's truly what you're finding there for those. Okay. So the value of D when t equals 4, well, this is just a basic algebra 1 type question. I know it's a trig function, but you're just plugging in 4 for t. So you can try to simplify it on your own. So it's 6 cosine of 3 pi. Or you can type it in the calculator too. So then what is the cosine of 3 pi? Cosine of any odd pi, any odd pi is -1. So then that equals -6. So that's the value. Okay. And then the least positive value of t for which d equals 0, the least positive value of t. So you just basically are setting this equation equal to 0. So you have 0 equals 6 cosine of 3 pi over 4 times t. Okay. And then we need to go about solving that. So how do you solve this? Well, you're going to divide both sides by 6. Remember, this is captured in here. You can't just divide by that inside. So you're going to divide both sides by 6. The amplitude really doesn't matter where it crosses the x-axis. If you recall some of the questions that we've seen, amplitude does not influence that. Our period will influence that. So where does the cosine equal 0? Or where does the cosine of 3 pi over 4 times t equal 0? So really what you're trying to find, when does this inside part make the cosine equal 0? Okay. So now we need to take we need to figure out where the cosine equals 0. Forget about this part for a minute. So where does the cosine equal 0 at? Well, the cosine equals 0 at pi over 2, 3 pi over 2, and then 5 pi over 2. And it does keep going, but we're not gonna keep going. We could, but we're not going to. So really what I need to do, I need to set this, because whatever this is, if it equals pi over 2, it'll make it 0. So whatever t is, if you multiply t times 3 pi over 4 and you get pi over 2, then the cosine of pi over 2 is 0. Or whatever t is, if you multiply it by this number and you get this, then it'll equal 0. Whatever this t is times that, if you get 5 pi over 2, then when you take the cosine of it, it'll equal 0. So you need to set 3 pi over 4 times t equal to pi over 2. And then you just need to solve that. So t equals pi over 2 divided by this. Well, when you divide by a fraction, you're really multiplying by the reciprocal. So what does that equal? Oops, I forgot to put the pi on the bottom. Sorry. Pi goes on the bottom there. Okay, so the pi's cancel. The 2 and the 4 also simplify, so that's 2/3. So if t is 2/3, then it will make the cosine equal 0. So that's a possible answer. Remember, we're looking for the least positive value. It is a positive value. So then let's try 3 pi over 2. So 3 pi over 4, t equals 3 pi over 2. And if you divide both sides by that, you're going to get 3 halves pi times 4 over 3 pi, right? Reciprocal of this, when you multiply, you multiply by the reciprocal. So those cancel. That just becomes 2. So that's another answer where this will make the cosine equal 0. And then I'm going to try one more to see if it changes, because if it just keeps getting bigger, then I know 2/3 is my smallest number. So then we're going to take 3/4 pi, or 3 pi over 4 t, and that equals 5 pi over 2. So then you're going to divide. So t equals 5 pi over 2 times 4 over 3 pi. So the pi's are going to cancel. The 2 is going to reduce with the 4. You're going to get 10/3, or you could just multiply 5 times 4, get 20. 20 over 6 is 10/3. So 10/3 is actually getting bigger, right? 10/3 is bigger than 2. So that's not going to be my answer. My answer is really 2/3. That's the least positive value that's going to make this statement true. Okay. The sooner you realize that it's getting larger, you can stop. I just worry. I tried a third number just in case if this decreased. All right. So that's simple harmonic motion. It's what we've been doing. We're just changing some of the terminology. And if you've had physics, you've probably already done all this, because they use these terms in physics. In math, we use just more regular standard terms. It would be nice if we could always use the same terms. But when we first learn it, we are using easier terminology, I guess, if you want to think of it that way. So again, how do you know which equation to use? If I got something bouncing up and down, then I'm going to use sine. If I have something bouncing left and right, like a pendulum on a clock, then you would use cosine. All right. So let me know if you have any questions.